This is exercise 14.3 now. You need to draw a number line to represent the possible values of the variables in each case. X less than 5. For that, since we need to do it on a number line, so we have to do it for a number line. We need to make a number line. And for this number line now, we need to have its arrowheads pointing on both the sides so that you can see that this is actually, you can say it as an x-axis started from 0. That means on right side of this 0, you have got the positive values of x, and on its left side, we have got negative values. Since we need to have the values of x to be less than 5, so if I do it like this, 1, 2, 3, 4, 5. For this to represent it now on the number line, I need to have the values of variable x which are lesser than 5. So lesser than 5 is this region. Now, since I need to say that I need to have the values of a variable less than 5. So at 5, I need to have a circle or a hollow circle. That would mean that 5 itself is not included. Rather, any value which is lesser than 5 is also included in this. I mean to say that if, for example, it is 4.1, that is also occurring in this range. If it is 4.9, even if it is 4.99 or 4.999999, any value which is lesser than 5 is a part of this solution. So to depict that, we do it like this. That means on 5, you need to have a hollow circle depicting that you need to include values which are lesser than 5 but not exactly 5. This type of inequality is called an open inequality. This is an open inequality. This is also an example of open inequality. But this is an example of a closed inequality. The difference between a open and a closed inequality is the same, that in open inequality, as I have done in this part, we do not include the end portion, end number, which is 5. But in this case, for closed inequality, we need to have values of the variable p which are lesser than 6 as well as 6, which is represented by equal to 6. So if I need to do it uh, for part C, it would be something like this. This is 0, for example, and here it is 6. So now to have this, I need to have a filled circle now, which represents that the number 6 is included in this case and values which are lesser than that. So P less than or equal to 6. So this is it. This is the difference between an open and a closed inequality. That means the end number is to be included in the case of a closed inequality, but the end number is to be excluded in the case of an open inequality. Okay. Now, in the same way, if I give you an example of part B, that means x less greater than 2. So if this is 0, this is 2. So the values of x should be greater than 2, not including 2. So At the place of 2, there is a hollow circle now. And at the place of part C for 6, this is a solid or filled circle. So that is the difference between the closed and open inequalities. Okay, with this, now I proceed to part D. Y is greater than negative 8 now. So if this is 0, this could be somewhere negative 8. So the values of y should be greater than that. So this is point and the values should be greater than that. This represents values of the variable y which are greater than this value negative 8. So this point is not included over there. So that's why we have made it hollow. Okay. So this is what you need to take care of. This is the representation of part D. Okay. For this part E now, this is 0. Here is negative 5. And Q should be having values greater than negative 5, as well as there is an equality sign. So I need to include it. So that's why I need to fill this circle like this. So this represents now Q is greater than or equal to negative 5. If it would have been, for example, if it would have been just Q greater than negative 5, so we would have done it like this and then this. So this would have represented Q greater than negative 5. So you need to understand the difference between these two types of inequalities. So the answer to given part E is this one. Okay. Now for part F, the values of x should be lesser than negative 4. If this is 0, for example, this is negative 4. So I need to have the values of variable x which are lesser than negative 4. So this represents x less than negative 4. Okay, now for part G, in between 1.2 and 3.5, exclusive, not inclusive. That means we do not need to include these endpoints 1.2 and 3.5. So this would be somewhere, let's suppose this is 0 and this is 1.2 and here is 3.5. So the values should be in between. At place of 1.2, I need to have a hollow circle because this is not included. This is an open inequality. And then same goes for 3.5. You see, like this. So I need to have a hollow circle here and all the values in between. So I need to represent it like this. So this represents the values of the variable x which are between 1.2 and 3.5. Okay. Then part H. Now you see here is an open inequality and here is a closed one. So this is 0. If here is 3.2 and this is 2.9 for example, so we need to leave negative 3.2 because this is not included. There is not an equality sign with this inequality. But here we have got an equality sign. So we need to fill the circle at 2.9 and then the values in between like this. So this represents part H. Now for part I, for example, positive 4.5, negative 4.5 and negative 3.1. Here is 0, for example. Here is negative 3.1. Then here would be negative 4.5. So the values have to be from here till here. And since the equality is a closed one, so we need to fill this circle as well as the other circle, and the values are in between. So this represents part I. Now we proceed to question number 2. Write down all the integers that satisfy each of the following inequalities. For part A, for example, we need to have the integer answers only. For example, if I draw the number line like this, so if here is 3 and here is 33, so I need to have the numbers which are between 3 and 33 like this. But now in this case, since I need to have the integer values, so no point of drawing a line like this, because line means all the values which are included. For example, what I mean to say is that this line means if there is a value 3.1, that is also a part of this. If a value is 3.9, that is also part of it. If a value is 4.5 or 29.98, whatsoever the values are, all these are which are within this range are a part of this solution. But since none of these are integers, so we need to just pinpoint the integers, not any other values. So there is no point of mentioning them with the form of a line. So what I need to I just need to have the integer values. So integer values between 3 and 33 would be starting from 4, 5, 6, 7, 8 up till 32, means lesser than 33. The maximum integer value is 32. So all these values, for that you do not need to give their answer on the number line. So the answer is to be written like this. And if, for example, you need to draw them on the number line, so you would be doing for this 4, 5, 6. So you are going to have points like this, like this, like this, and up till 32. This is it. For all the numbers in between, you need to have these solid dots like this, and no need obviously for these two end values. So that would be a representation of all these integers on the number line as well. Since that is not the requirement in this question, so let me not draw them, and the answer is going to be this as I've written it. Okay. Now, for part B, values of h greater than 7 but lesser than or equal to 19. This is a closed inequality at this end. So you need to include 19. And there is an open inequality. So you need to exclude 7 greater than 7. So for part B, the answer would be starting from 8, 9, 10, 11, 12, 13, up till 17, 18, and then finally 19. 19 has to be there, but 7 has not to be. So 7 is not written. We have started from 8 and gone till 19, writing all the integer values. Similarly, for part C, 18 till 27 inclusive. So 18, 19, 20, 21, 2, 3, 4, 5, 6, and 27. All of these values have to be included. And for part D, -3 lesser than or equal to f less than 0. So you need to have -3 is to be included, then -2, then -1, and that's it. 0 is not to be included because there is an open inequality. So that's the answer to part D. For part E, we need to have -3 and 0 both inclusive. -3, -2, -1, and then 0 because of this inequality. And then for part F, 2.5 till 11.3. So 2.5 is lesser than m. That means m itself is greater than 2.5. So after 2.5, the next integer is going to be 3. So you need to start from 3, then 4, then 5, 6, 7, 8, 9, 10. And the value of m should be lesser than 11.3. So the maximum integer is 11. So this is how we need to do it. And since these represent all of the, so we are bound to write them down in the form of sets like this. And then this one, this one. These are the values within this set. Or then for part G, -7 till -4, but greater than -7 and lesser than or equal to -4. So this will give us -6, -5, and then -4. Then part H, values of r between pi and 2 pi. And since this is, let's suppose 1 pi and then 2 pi, and we need to have the integer values. Solving it out, like for example, uh, since you know that the value of pi is 3.14 and multiplying that value with 2, you get 6.28. So the values of r should be, and 2 pi 2 times 3.14, which is 6.28. Integer values greater than 3 and lesser than 6.28. So start from 4, then go till 5, and the integer 6 is lesser than 6.28, and the integer greater than 3 is 4. So we start from 4 and end till 6. So that is the answer to part H. Then finally part I. Square root of 5 and then square root of 18. So for part I, the answer is if you solve square root 5, you get 2.23, and square root of 18 is 4.24. 4.2. So the values of W should be greater than 2.23 having an integer value. So the next digit or integer, sorry, after 2.23 is 3, and then 4. That's it. And we do not need to go beyond 4.24. So we cannot write 5 here. So 3 and 4 are going to be the only integers included in this solution. So that completes question number 2 as well. So that completes exercise 14.3.